In this video, we're diving into the concept of the empty interface in Go. We will understand what interface character is and what the any type is in Go. So, what exactly is the empty interface? The empty interface specifies 0 methods. Because every type implements at least 0 methods, it means every type satisfies the empty interface. Take a look at the code example. We declare a variable x of type interface entry. Then we assign an integer value of 42 to x. Then a string value of hello. Then a slice of integers containing 1, 2, and 3. And finally, a map of string to integer. This is possible because the empty interface can hold any value of any type. Use interface when you need to store values of unknown or varying types. It is perfect for generic data containers and APIs. Consider the following function named store, which accepts a variable number of arguments, each of type interface. Inside the function, we iterate through the values and print each value. We then call the store function with an integer 42, a string hello, a boolean true, and a float 3.14. Type assertions are used to convert an interface back to its underlying concrete type. There are 2 ways to do this. The first is the safe assertion. We declare a variable x of type interface and assign it the string value hello. We then use a safe type assertion to check if x holds a string. If it does, we assign the string value to s and the boolean value true to OK. If OK is true, we print the value of s, which is hello. The second is direct assertion. We declare a variable x of type interface and assign it the integer value 42. We then use a direct type assertion to assert that x holds an integer. If x does not hold an integer, the program will panic. Otherwise, we assign the integer value to I and print its value, which is 42. Use a type switch to handle multiple types efficiently. It provides a clean way to process different types from an interface S. In the code example, we use a type switch to determine the type of the variable x. If x is a string, we print string followed by the string value. If x is an integer, we print integer followed by the integer value. If x is a boolean, we print boolean followed by the boolean value. Otherwise, we print unknown type. This is an elegant way for type handling. Go version 1.18 introduced a cleaner syntax for the empty interface. Any is a type alias for interface dot. It provides the same functionality but with more readable code, and it is perfect for modern Go development. Looking at the code block, the old way to declare an empty interface was var x interface dot. The new way is var x any. Both are identical since type any equals interface dot. Modern Go code prefers any over interface quote. They have the same behavior, but any provides a cleaner syntax and better readability. Let's look at an example. We define a function named process that takes a parameter data of type any. Inside the function, we use a type switch to determine the underlying type of data. If it is a string, we print text, followed by the string value. If it is an integer, we print number, followed by the integer value. We then call the process function with the string hello and the integer 42. It's time to embrace the modern syntax. Here are some best practices to keep in mind when working with empty interfaces. First, use any instead of interface.strs. Second, always use safe type assertions. Third, prefer type switches for handling multiple types. Fourth, use specific interfaces when possible. Here are some practices to avoid. First, avoid overusing any everywhere. Second, avoid direct assertions without checking. Third, avoid using any when concrete types work. Fourth, avoid ignoring type safety benefits.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.